Hi, everyone. Welcome to Beyond the Grid. This is a special in-person episode. We are here with Wes Short, who is the Senior Director of Infrastructure Projects. We are live in Austin, Texas. This is the barbecue edition of Beyond the Grid. We are talking to Wes because if you ask who is the MacGyver of our company, the answer is always Wes. What I appreciate most about him is that he sees the whole picture. He's not just trying to make things a little bit incrementally more efficient. He's really trying to solve the whole problem at once. So with that, please welcome our special guest, Wes.
Thank you.
Thank you, Wes,
Glad to be here.
Yeah, fantastic. I want to kind of explore the tinkerer background in you.
Yeah, so love tinkering, love building stuff. I was young. I think about my first welder when I was like 9 or 10 years old because of the bracket. But the bracket for the back of the lawnmower to hook the trailer up was like $400. I'm like, I'm not spending $400 on a metal bracket. So I bought a welder instead and welded and made my own bracket to haul the trailer behind the lawnmower.
You're your own problem solver.
Yeah.
It's amazing.
It can be a problem though.
Yeah, exactly. You should see my garage. One of the things when I first met you, which I was really impressed by, was that you have this bizarre educational background of physics and cartography, and I just don't know how that happens.
It's quite the story. Been blessed more than anybody that I could ever imagine, and just the upbringing, my family, was a phenomenal experience. So went to college, had a small lawn mowing business when I was very young, and in reality it was all about the work, but it was more about meeting people, and that's why my dad was totally fine with me having a pretty nice little lawn mowing gig. I get back from college first year, I'm standing on the guy's roof. He's like, "Hey Wes, you want a real job?" I was like, "Okay." He's like, I know this electrical contracting company. I'll give you a good word." Well, little did I know he owned the company. So I went and worked for them for a summer, went back to college, changed my major, and I get into construction management. So got into construction management, electronics, got done with school a little quicker than what I really wanted to. So I stayed another year. The deal was I had to get another major for every year. So that was kind of like my marching order. So I stayed for the fourth year and did a community and regional planning because I was really wanting to kind of see what the cartography side was at with the community and regional planning, and then be able to design these crazy buildings in Revit with all the analytics inside of it. So kind of blended those together, kind of changed how we looked at cartography, at least in my opinion. And then during my senior year was on a advisory committee to get an architecture degree started. So triple major 5 years.
So you've been an overachiever a long time, is what I'm hearing.
I like working. I like punishing myself to work and learn.
I love that. How did you get to Endeavour?
Been in the electrical business for 20 some odd years. Worked at an amazing electrical contractor. Ran the engineering department for about 10 years. Been building data centers for probably the past 6 to 8 years, 10 years. Real heavy in data centers. Got to work with all the different hyperscale partners and clients. But wanted to change. About a little over a year.
Amazing.
Here. Didn't really totally understand the ecosystem I was getting into.
Yeah.
But the more things we look at and the more tech we get to look at, really just that ecosystem just blends together.
Yeah.
To try and explain that, or for me to even begin to wrap my head before I got here, it would be like, nope, that's pie in the sky. I don't need to hear about that because it's not true, and I'll be darned if it isn't true. It's like, no, I do that every day now.
Isn't what Endeavour, making the impossible possible? I think that's our new sub-tagline.
Yeah.
I think the very first question I asked you when I met you, when I just started, was what keeps you up at night about this work? And your answer was grid stability.
Yeah.
Maybe talk about what is grid stability to you? Why are you worried about it? How does it work?
Power leads to just about everything. Everybody needs water. Everybody needs food. Power gives us that access.
Yeah.
when you think about, if I have to waste my energy to do something, I waste that energy to get my energy.
Yeah.
If I have a hoe or a plow or whatever, and I waste that energy and I eat that energy, that's just a 1-for-1.
Yep.
When we can produce power, I don't have to exert that energy.
Yeah.
So then I can do other things. The other things that we do are what are very important. But if we lose that ability to have that outside power that we are not actually generating or putting into the earth or whatever it may be, the delta between those two is critical. Yeah. And that is grid. That is the grid. That's being able to get your lights to turn on or make a phone call. Like little things like that are just a bump in the road. But if you actually think about grid stability, if we lost all grid for a substantial amount of time, what are people going to do?
Do you feel like what happened in Spain this past spring is an indication of what it looks like when the grid goes down? Or do you think it could be,
it could be a lot worse. You look at what happened in Spain. It was a terrible event, oscillations, whatever, grid anomaly. They knew, like everybody outside of Spain, all the power companies knew there was a problem, and they actually did what they were supposed to do. So they disconnected from the grid, or disconnected Spain from the grid, so that that problem that they were having did not go all the way through the European Union, which if we think Spain was bad, think about if that thing had gone all the way across Europe because they didn't disconnect. Now, what is very different is we, and I believe, data centers can provide a much larger play when we get into grid autonomous frequency control and stuff that
you're going to have to define that.
Done here in Endeavour.
Great, yeah.
For quite some time. That's where the play is. I firmly believe that's what we can do, but we have to change how we think about good interconnects. And, I want to put generation on site. Utilities like, they have to do a massive study. We've got to automate how fast the studies go. We can automate how fast the studies go by AI. So it's just like the nuclear reactor programs and stuff like that to get, Trump's big push and the current administration's big push is to use AI so that the 80,000, 800,000 pages of documents that people have to go through doesn't take 10 years to go through that documentation, run through AI, make sure we get very educated decisions and get the green light.
Amazing.
As opposed to waiting. Grid should be doing the same thing.
Interesting. Is that likely to start happening?
We have taken grids that through time have not been the smartest things, and we've built that for the past 50, 60 years.
Yep.
Transformers haven't changed much. Infrastructure hasn't changed much.
Yeah.
EVs was like a big, what is happening?
Paradigm shift.
We've got everybody, guess what? This is a novel concept. Everybody comes home at the same time and plugs all of their EV cars in, and guess what?
Makes dinner.
I smoked a transformer down the road.
Yeah.
Like that was just those small little things that people really didn't think about. That was the reason for the interns.
Yeah.
Was to take AI, figure out how to do this, and to make these grids smarter so that we can be, back to Spain in the original question, we need to make, just like a data center, we design the reliability, the number of nines. We need to take that and be able to push that further down the grid so that the grid instability might only be one little line way out somewhere, somebody's neighborhood, and just turn that off as opposed to that neighborhood problem or that medium voltage problem, high voltage line problem, and cut that one as opposed to it going all the way and having a countrywide outage, which is, you need to have better. It's good and bad, right?
Yeah.
It could have been a lot worse.
Yeah, for a lot longer. That's very true.
But the system worked.
Can you explain number of nines real fast? That was something that was a new term for me when I got here.
Yeah. So number of nines is like 3 nines, 99.9% all the time.
Uptime. Yeah.
Then you got 5 nines, 99.999%. And there's dollar values associated with that.
How many nines you have?
How many nines. That changes how we engineer the data center, the number of, the amount of equipment.
Yeah.
Not to get too technical, but it is, when we get to these mega sites, it is unbelievable amounts of dollars when you just add one more nine. I mean, first data center ever built was like 2 megawatts, 3 megawatts.
Sure.
Like,
that's so amazing. It took me a while to get my head around what is a gigawatt. What I heard was it's anywhere from 750,000 to 1,000,000 homes, the equivalent. Is that about right?
depending on where you live and all that kind of stuff. But yeah,
Yeah.
it is a lot. We can't really use the calculator on the phone anymore because it doesn't have enough commas. So we'd have to type all this stuff in Excel because we hit the little column or comma button so that you can actually start thinking about just the numbers. Or
Too many zeros.
Too many zeros.
Too many zeros.
Too many zeros.
I heard that China was moving at the pace of 3 gigawatts a day of solar and also still doing coal as well. But I'm just wondering how do you think they're accounting for such enormous switches of power at that rate? What are they doing for stability, do you think?
There's a lot of different ways to do it. How exactly they're doing it, I don't necessarily know. But as long as, we had a major shift here in the States where we shut down a lot of inertia and just went with renewables.
Yep.
A blend of inertia and renewables is definitely the right way to go. And my guess would be yes, we want to do the renewable, but at the same time, we still need some of that just inertia on the utility grid to keep the stability.
Yeah.
So I think that's why we're seeing a lot of play between, in China specifically, renewables, inertia. There's still turbines and stuff like that, which have their own set of issues, but it's a lot easier to just work in partnership with each other as opposed to just saying, hey, let's
just go all the way.
8 gigawatts of solar in this week and
exactly. See what happens.
Yeah, see what happens.
Speaking of turbines, let's talk about TurboCells and the role that they're going to play in grid forming power.
Yeah. So back to the Spain issue where, when there is a grid event and we have all these systems that isolate themselves like a data center, that grid event happens, that entire data center comes offline.
Yeah.
And when I say it comes offline, it comes off grid.
Okay.
So they turn on their generator, they open their utility mains up, they become their own little island. The problem with that is if there is a grid event, guess what? All the data centers, so if you go to an area that has a massive amount of data centers and all of the data centers, gigawatts of power just came offline, this generation plant that was running at 100 megawatts, or just keep low numbers, 100 megawatts just lost 50% of all of its load, base load. What that thing's going to want to overshoot and go through. And that's where these anomalies are happening. These issues actually go back into the generation plant. But when we talk about TurboCell, fundamentally, we do not want, and our data centers will not break from the grid, because the way that we are designing the TurboCell is to have that power electronics, that brain, that autonomy to be able to stay connected to the grid. So when I have a hertz swing or some sort of anomaly, I'm going to stay on that because we're going to be able to use the power electronics to actually stay locked on, be that anchor. So if we have, let's say a 60 hertz system here in the States, if it goes to 57 hertz, everybody in the world would be disconnected. We're going to stay hammered. We're going to stay on, and we'll deal with that through the power electronics.
Is anybody else doing that?
I believe there are a couple people doing it, but the philosophy and, one of the visions of Jake is to be able to do this in a data center company that is vertically stacked. I mean, there's nobody like that.
No.
So we get to make decisions like that. We get to set our own impact goals. Yeah. So if I want to make an impact, I'll go invest in a new company that'll make impact that works for the data center and for mankind.
I love that.
Yeah.
Speaking of impact, the story that we hear a lot is about energy. We're going to run out of energy if we try to support AI-based data centers. Water used to be the story. Now power is the story, but you see a time when water is going to go back to being the story.
Yeah, I mean, fundamentally, not to get too rudimentary, but food, water.
Yeah.
Power's something that's nice to have.
Yeah.
Fundamentally, that is what drives people, food and water. Power, we have the AI boom. We have all the data centers getting built. We have transmission constraints. We produce a lot of power. Can't get it anywhere. Goes back to that whole AI land planning, years of permitting, all that kind of stuff.
Yep.
But if you think about it, water will be gold again. It was a couple years ago. Then we needed power. It's going to go back. It's fundamentally food and water will always be gold. It's just which one's a little higher at a certain time. And that, water's going to be the next thing that everybody's got to figure out in a data center. We don't evaporate water in our data centers. We have, thermal works, unbelievable systems. You got to tweak the system out for the past 15, 20 years. It has been a constant learning lesson.
Yeah.
Tinker. Let's figure out how to pull all the heat off of it so that we're not actually creating these heat islands and stuff like a traditional data center or big city would. How do we give that into actual district heating?
Yeah.
Guess what? We got Danfoss and those guys, and we're just going to be able to give you 60 degrees C heat. Guess what? We could put a small heat pump and give you 90 or 100 C heat. Like, those are the things that somebody would have to go in and do. We do that because it makes everything better.
Yeah.
For everybody. It makes it better for the data center, makes it better for the community. And now the communities that don't want the data centers are going to go, wait a minute.
I'm going to get free heat out of this?
I can get free heat. I can do this. You're going to actually stay online. You're going to make my community better.
Yeah.
I like that idea. They'll get on board then.
One of the things that we've talked about is, could the data centers almost become a mini utility of the future? And
I think they could. I think if we actually look at what the data center does, data centers everybody's got a different flavor of what they think a data center does for a community.
Yeah.
But if we actually took a data center and built an ecosystem around it, like the Endeavour ecosystem, that massive data center that only has like 20 people working inside of it, it's a huge building, eats up all this power. What if we actually took all of the byproducts, the waste heat, all these different things, and made it so that instead of only having 20 people, you had 200 people, 2,000 people.
That's right.
We brought that full ecosystem in. Now the community is going to get a lot of jobs. We can have farming. We can have alternative fuels. We can have all the different
new materials,
impact
yep.
programs that we've got working on, new materials.
Yep.
So now you've got a full ecosystem. Look at how Europe's built a lot of their towns. They've got a community around it. They've got an industry around it. And everybody kind of stays in that little area. And it's a very cool, microeconomic community that they get to do a lot of the decision making of what and how they want to run that area, because everybody's dependent on whatever that original anchor was. That anchor needs to be data centers in the future.
Needs to be.
Yeah.
I think it's something like $7 trillion of investment will be coming just in the next 5 years alone. It's been a 10x ramp almost year over year, something like that.
Yes. The numbers are just astronomical.
Yeah.
It's 10x, 20x. It's not a linear curve. It is an exponential curve that does not seem to be slowing down one bit.
It's not a bubble.
I don't think it's a bubble.
Yeah.
No. I think how we treat the data center and how we implement the data center will 100% affect that bubble. If we do not understand what we're doing or do not look at the full impact of what that data center is doing, we could very easily make this a very quick bubble.
Interesting.
It's different.
Yep.
Got to think big picture with it.
I agreed. If it can be that anchor or that engine for a bigger sort of economic ecosystem and hopefully societal benefit ecosystem at the same time, then I think we're going to be in good shape, to your point. What are some of the unexplored sources of energy that might be coming down the pike?
There are so many that we get to look at every day. It's fission, fusion, cultivating alternative sources of energy, whether that be from the ocean or the land. I mean, there's
wave energy.
There's cold sink to space, go to space. It's just mind-boggling how many brilliant people have thought about different ways of doing it. We just always have to be thinking bigger picture.
Yeah.
Renewables haven't got the greatest push. It's been rough with the renewables because we've subsidized them so heavily. So they pencil right now, but will they pencil later if we take this away and this away and this away?
I think we're about to find out.
We are about to find out. But, it's funny. I've spent a lot more time in the past 2 months working on solar, knowing that these are going away. These subsidies are going away. I've spent a ton of time with solar and how we actually use solar with data centers to get not necessarily just a green, but how do we actually make it so that it works in the ecosystem?
Yeah.
If I put a battery in, I could get commissioning running. I don't need 200 megawatts day one. I only need 20 or 40.
Yeah.
That is very easily a play. And then obviously anybody that's bridging, if you have renewables, that offsets fuel cost.
Yep.
That's a no-brainer.
Agreed. One of the things I get really excited about is how your interns came together this summer. And you had some smart interns and you directed them really well. Maybe of the projects that you saw go through, which ones might keep going forward?
Power electronics team's working on, so we've got some IP out of Georgia Tech where we can take a sine wave or any kind of form of electricity, chop it at 18 kilohertz, and augment that sine wave however we want.
Mm-hmm.
So it's software-defined voltage input and output. So I literally go on the computer if I want 415 AC, 240, 480, 600 volt, as long as my infrastructure is already built around what we know we want to do, then we can do that. So future-proofing is a very wide open term.
Yeah.
If you can actually explain and show people, hey, your infrastructure is designed right now for 480, 415, whatever it may be, can literally show them how we're going to go to 400 volts bipolar DC architecture every step of the way. And that's one of the things most people don't think about. GPUs right now have, before GPUs or chips would last years, now the economic decision is I just spent billions of dollars on chips.
Yeah.
Next year's chips are 125, 150x over last year's chips. Is there a decision to be made to chunk all the old chips, build a new data center to get newer chips?
Yeah. I mean, that reminds me of just the bridging power conundrum in general, like that people would come in and build these entire infrastructures of energy that they would rip out and trash almost.
Yeah.
And so how do we get away from that as well?
Yeah. We've got to, I won't tell you exactly how long I spent, but it was for a hyperscale data center. I spent months just designing and trying to VE a bolt assembly for how we would hang tray. 6 months, design a bracket. We went from millions and millions of parts to a one-handed operation where you could pick the bracket up, already had a bolt, a nut, ready to be installed so the guy could pick up the part out of the bucket or the bin and literally have his hammer drill or impact driver in the other hand and literally just connect it, as opposed to 4 hands trying to level this thing out. I was like, no. Millions of parts.
This is your welding background coming back. I think it is. I think it's the tinkerer in you that saw the answer.
It's like, if I wouldn't want to do that personally, I don't want anybody else to have to do that.
But seriously, sometimes it's that hands-on experiential know-how that makes the difference.
Yeah.
Any other intern projects that you want to see go forward?
Pretty biased on the group of stellar guys that I had. We've been working. I had a buddy that came up with it. He was working out in a utility. He's like, I have no idea where all these power poles are. So I was like, oh, all right, well, I'll write you a drone code.
Hold on. We have to slow that down for a second. Someone who worked for a utility didn't know where his utility poles were.
It happens all the time.
Wow.
So, I mean, you think about it. These utility poles have been going in for 100 years.
Yeah.
They don't always know where they are.
Yeah.
Somebody clips one, they move it, they do whatever.
Yeah.
They just don't necessarily know where they are. So the thought was, is if you took a LiDAR camera on the end of a drone, you could figure out if you were over top of a utility line, fly the utility line, see what we could pick up, cameras, LiDAR, all that kind of good stuff. Went a little too far. That would have just been tremendous amount of drone time, and it would be more searching, right? Just trying to find the utility lines. Thought process was, hey, what if we step back, use what's already been done before? So we ended up taking a lot of existing imagery from various sources, run it through an AI machine, and then we train the AI model to find grid infrastructure. So they could find a transmission.
Transmission.
Yeah, they could find transformers. They could find cat banks. They could find fuse cutouts. They could find all this stuff on a pole. I was like, hey guys, my pink elephant or pink unicorn is I want to see if you guys can find the splices on the utility line. So the little splice is maybe a foot long on a utility cable that's 50 feet in the air. And somehow they did. I'm like, you guys have got to be kidding me. I've been trying to figure this out for 5 years, and you guys got it done in one intern project in the summer. It's got
to be worth so much time and money for the utilities.
I believe it is. Yeah. And I think they're probably doing something similar to it. I've just never really seen anything like it. But we've got a set of CTs.
Set of CTs?
CTs, current transformers, so it can tell how much amperage is coming through the cable. We take the AI, the machine learning model, we go to an area where there's a utility, say, hey, this is how many utility transformers you have, this is how many of these things you should hook up. And oh, by the way, back to the original question, when I want to be able to see what's happening way further down, make those nodes very small, that impact area small, I can actually follow that all the way through with those CTs down to the house level if I wanted to. And I can fix that issue that starts somewhere, gets stopped there, not way back at the country level.
That's amazing.
Yeah, that was, can't always tell everybody what you're trying to do, or they'll just instantly go way too far into the weeds.
Yeah.
Gotta, especially young people, you've got to lead them, got to just push them a little way, and then when they start seeing the picture, you just give them the next breadcrumb, and then they start looking at it together. And the minute they do that, they realize they're getting the breadcrumbs, then you got the next leader. That's how you get the next generation of leaders.
Interesting.
You show them how to make the breadcrumb for the next person they're going to train. So that constantly, every manager should be training and teaching the younger guy to replace you. Always, train and replace.
I really love that. It's just a great managerial model.
Can't ever lead from the back or lead from the front. You've got to go. You have to be able to know when you should be in the back and when you should be in the front.
Yeah.
And it changes every day.
Yeah,
it changes with each person.
Well, my last question for you is about the future. Whether it's energy demands, waste heat as a concern, where we should put data centers. What do you think is, maybe it's 10 years from now, we're having another conversation. And you're like, the thing I saw coming, Beth, that maybe not everybody else did was.
Oh, man. It's what keeps me up at night. I think fundamentally right now, using water, got to figure out how to get rid of the water in the system. So heat transfer, thermal transfer, cold plates and all that on the GPUs is already maxed out, taxed. There are alternate cooling systems, whether it's liquid helium or other forms of gases. Got to figure out a way to get more economic in how we cool at a much higher and denser scale, or higher and denser scale. So I think whether that's on Earth, that's outside of Earth, a lot of people are like, well, we can do immersion cooling and we can do all this. And it's like, if you put a data center in the ocean, there's no question you're raising the temperature of the ocean.
That's right.
There's no denying that.
That's right.
That, to me, is not the sustainable thing to do. We've got to be thinking about the next 10 years, 50 years, 100 years, and start putting the little breadcrumbs in place so that when we start thinking about it as a full ecosystem, we're zero impact on a data center. Think about if we could build a data center, and the data center was at the start the source of everything around it. There's no reason why in the future that gets flipped.
Mm-hmm.
So the data center may initially be that anchor, but then it's the farm, it's the greenhouse, it's the renewable fuels, it's
a cycle. I love that you hit on the point around there is no free energy by putting hot things into cold places.
Yeah, we have to be thinking about different things. Shoving something in water
May not be the answer.
may not be the answer.
Oh, wait. Last question for real is how many of your 4 children will be going to the data center business?
Whew. They already have a couple GPUs. Got a couple of them sitting in the.
They know how to weld.
They definitely all know how to weld. The next 10 to 15 years are going to be really fun.
Yeah. Wes, I'm so grateful to you for being here today. So thank you for taking the time. It was an amazing conversation, like it always is when I get to spend time with you, which is too rare, by the way. I'm hoping for more. Thank you, everybody, for tuning in to Beyond the Grid. It's so special to be here in person with the rest of the team, and we appreciate your time. So we'll see you soon.